So 5.3 is about transformations. It is one of the most important lessons that we do this year. I kept waiting. When is this lesson going to happen? But remember, a transformation is just how we move a two-dimensional figure around the XY plane. So we're talking about stretching it, moving it up and down, left and right, flipping it over the x-axis or the y-axis, all those different things, okay? So the first thing I want to talk about is how do we move the function left or right? Now, anything we want to do that moves the function horizontally, a left and right movement, always has to be done on the inside of the function. So to move a function left, you're going to add on the inside. So if we have this g function and we want to move it left 2, you'll notice how I've added 2 on the inside. So a horizontal transformation of any sort has to happen to the x's on the inside. If you want to move a function to the right, the rule you have to remember is that you're going to subtract on the inside. So you'll see here, I've taken my g function and moved it to the right 4 by subtracting 4 on the inside. So it's very important that you know, hey, I want to move a function to the left 2, I'm going to add 2. If I'm going to move it to the right 2, I'm going to subtract 2. So add on the inside moves it left, subtract on the inside moves it right. So anything we want to do to move something somehow or change something horizontally, left and right, we have to do it on the inside. And it's always the opposite of what you're expecting. And the reason being is if I set that x plus a equal to 0, I would have to subtract a. So it does the opposite of what you should expect. So now let's talk about how we move a function up and down. If we want to move a function down, we have to subtract on the outside. Anything we're doing to change a function vertically will happen on the outside of the function because it's happening to the y value. So if we want to have less than, we need to take f of x minus b. If we want more than, we want to have to take f of x plus b. So adding on the outside moves it up, subtracting on the outside moves it down. So you can see some examples here. If I've taken my g function and I want to move it down 4, I subtract 4 on the outside. If I want to move it up 7, I add 7 on the outside. So if I want to move a function up or down, I have to do it on the outside of the function. So it's very important that we know how to move a function up and down. Now let's talk about flipping a function. If we're flipping a function up and down, that is flipping it or changing it vertically. Anytime we want to change it vertically, we do something on the outside. So to flip it over the x-axis, we multiply on the outside by -1. So that's what happened here to our g function. I've multiplied on the outside by -1, and I flip it over the x-axis. If I want to flip it over the y-axis, I need to do something to the inside because that's changing it horizontally. I multiply by the x's by -1 on the inside of the function. It is the opposite input. And that's going to flip it over the y-axis. So if I multiply by -1 on the inside, I'm going to flip it over the y-axis. The one that's probably the hardest to wrap your head around, and I'll show you more examples as we go, is if we want to shrink it or stretch it. So anything that we want to shrink or stretch vertically has to happen on the outside of the function. If the function is multiplied by something more than 1, like 2, it's going to stretch its height. It's going to double its height. But if I divide by 2 or multiply by 1/2, it is going to compress its height downward. So it's going to be half the height from the x-axis. Here it's going to be double the height from the x-axis. So we should expect that if we do something to the inside, it should change it horizontally. If we divide by a number bigger than 1, it's going to widen it. So it does the opposite of what we expect. If we divide by 2, it's going to widen it. If we multiply by 2, it is going to compress it closer to the x-axis, or to the y-axis. So it's a comparison of the distance to the x-axis here, and this one is how does it relate back to the y-axis. So you have to know those transformations. It's super important. We're going to use those for the rest of the year, even when we get into our trigonometry. When we go to graph our trig functions, we will need to know these transformations. Now, the trig function transformations, they actually use slightly different terminology, but same thing. If I add on the inside, I'm moving it left. If I subtract on the inside, I'm moving it right, and so on and so on. So it doesn't matter what kind of function it is, whether it's a trig function, a polynomial function, an absolute value function, a square root function, any of these functions, they will all do the same thing if we do the same thing to the function. So all of these transformations are universal. It doesn't matter what kind of function it is, as long as it's a function. If we want to move it or change it in this way, that's how we do it. So that's why it's so important, is this happens to all functions. This happens to all functions. Doesn't matter what function it is, that is the rule to transform it in that way. So you have to know these rules. These are super important as we go through this process. So now we have the rules written down. We need to take a look at some examples, okay? So make sure everybody has your rules written down. Let's take a look at the examples. So in the examples, we've had these functions, and we want to describe the transformation. So A is f of x in terms of g of x. What did you do to the g of x function? Well, if you add 4 on the outside, you are going to take the g of x and move it up 4 units. So our g of x function has moved up 4 units, and that's how we got f of x. We've taken our g of x function and we've moved it up 4 units. Now, B, we have something that has happened on the inside of our function. That is going to move it somehow left and right. It's going to move it horizontally. It's going to change it horizontally. If you're unsure of what happens, it's not a bad idea to set that inside equal to 0 to see kind of where our center has shifted. Our 0 has now shifted to 7. 7 is to the right of 0. So you can say that our f of x function has moved 7 units to the right. So anything we do on the inside of the function always kind of does the opposite of what we expect. Anything that happens on the inside of the function does the opposite of what we expect. Okay, it does the opposite. Now, C has 2 transformations. So I think of it in an order of operations sort of way when I describe it. So the first thing that hits my K function is that t plus 3. So remember, t plus 3 equals 0. That center has now moved to negative 3. T has moved to negative 3. So our K function has moved 3 to the left. But we have that minus 5 now next that hits the function. That's on the outside of the function. That is going to change it up and down some way vertically. So it's going to move it down 5. Anything on the outside of the function will always affect it vertically, up and down. Okay? Anything on the outside of the function will move it vertically, and it kind of does what you expect it to do. It doesn't do that opposite weird thing that anything on the inside of the function does. Now let's do D. We have this h of x function, which is equal to negative 2 g of x minus 7. So the first thing that happened, both things on those transformations occur on the outside of the function. So let's talk about the multiple of negative 2. What does that negative 2 do? Exactly. That's great. I think of it in two steps, kind of like the way you said. It moves it or flips it over the x-axis first, and then it stretches it out by a factor of 2. It stretches it away from the x-axis by a factor of 2. So it kind of does two things, and that's great to notice that. The negative does one thing, the 2 does something else. If it was negative 1/2, it would flip it and then compress it closer to the x-axis. Okay? But then we have that minus 7 still on the outside. It's going to move it down 7 units. So I kind of go order of operations. What touches it first? Is it on the inside? What did that do? It's on the outside. Kind of go in order of what touches the function first, and do your order of operations. That can help you kind of describe what happens and in what order. So when iMath asks for you to describe the transformation, that's what they're looking for. How did that function change from the original function? Any questions about number 1? Okay. Now let's take a look at number 2. It says the graph of G is given here in blue. So here's our G function. And we want to find F and H and K. So let's start with F. F I am going to draw. Remember that x plus 1 equals 0 at negative 1. So that tells us that we have moved left 1 unit. So let's take the 4 good points that are labeled on this graph, and let's just pick them up and scooch them over to the left 1. So this point down here goes to the left. The vertex moves to the left. All of these move to the left 1 unit, and now let's draw our parabola. So there is how we would graph f of x. Now let's graph h of x. Now h of x is a negative g of x minus 1. So let's do it in phases. The negative g of x is flipped over the x-axis. So I'm going to take and draw that original flip kind of in a little dashed green line, okay? So if I take, this was up 7, now just flip it down 7. This was up 7, now let's flip it down 7. So let's first do that. And again, like I said, I'm going to kind of make it a dashed graph. It still hits at negative 3 and positive 3. Think of that as its kind of swivel point. So like you have a little, it's stuck there and you're going to rotate it around that point. So those points, the x-intercepts stay the same. But instead at 0, negative 9, we are up at 0, positive 9. We've gone up 9 instead of down 9. And then let's make that graph. Now that's what the graph would be if the graph was just negative g of x. It's the flip of it. But we have that minus 1 on the outside, so we now have to move it down 1 unit. So I like to do it kind of in stages. Follow your order of operations. So now let's take my dashed green graph and take all those points we found that are really pretty, and let's just scooch them down 1 unit. So this one goes down 1, down 1, down 1, down 1, down 1. So that would be our final graph. Now, if you don't want to show the dashed one, or you want to erase it afterwards so you can see it a little better, if you're doing it on paper for me, that's fine. You know, iMath, I don't know if it's going to let you do it in phases like that, but if I were thinking about it, that is what I would do. And then finally, we're moved on to graph C. Now, this is one where a flip, you know, we don't have to flip it and then move it down one, but we can do the two transformations relatively quickly on the same graph. This part means that the new center of this graph, or in this case, our vertex, was moved to the right. So I have to move this graph 2 to the right, and I also have to move this graph up 1. Now, if you want to move it 2 to the right and make a little dash version, and then move it up 1, that's fine. But I think it's going to be pretty nice to just take each one of our nice original blue points and move them 2 to the right and up 1. Okay, so let's do that. So I'm going to take this one and go 2 to the right, up 1. I'm going to take this point here. I'm going to go 2 to the right and up 1. Now it's kind of, you can't really see it. Just guesstimate where that's at. It's about right there. This one's 2 to the right and up 1. This one's 2 to the right and up 1. This one's 2 to the right and up 1. And so now let's graph our parabola. Doesn't have to be perfect. But that's approximately what we want, okay? If you're doing this on paper for me, different colors can help. You'll notice, you know, I've kind of highlighted. This one was my red one. This one is a green one. And so differentiating by color is very helpful too. Yes. Oh, really? It'll do parabolas. That's cool. Thank you. Okay. Any questions on number 2? It's got to look better than my mess, but now let's take a look at number 5. It says the graph in blue is f of x. The graph in red is g of x. Describe g of x in terms of f of x. So I want g of x to equal some version of f of x. So let's go ahead and kind of mark out some really, excuse me, nice points on this function. So those 5 points are really kind of nice points there. And let's think about the fact that each of those points, you can clearly see with this one, 1, 2, so I'm going to here, 1, 2, 3, 4 to the right, 1, 2, 3, 4 down. And they all do that. 4 to the right, 4 down. 4 to the right, 4 down, okay? So let's write down what happened. So to get from the blue graph to the red graph, I've gone 4 to the right and 4 down. To move something to the right, we need to subtract on the inside. So that would be, excuse me, x minus 4 on the inside. To move a function down 4, we have to subtract on the outside. So that's all you would need to tell iMath what is our new function. Well, our new function, we went 4 to the right and down 4, okay? So that's it, that's the answer. Let's do one more. Anybody notice something that happened differently for number 6 that didn't happen for number 5. It seemed to get flipped over, right? Okay, so let's go ahead and figure out what happened. So I like to kind of find kind of the center line. Let's go ahead and just kind of show that little line there. And that new kind of center line is up here. And you might be able to tell now that I've kind of pointed out that little center line that we flipped across that line. Now, anytime you flip up and down, that means we need a negative on the outside of the function. So, in this particular one, we have flipped vertically. So up and down, okay? Now also let's take a look, this is a good point, this kind of center between the bumps. So I think these 2 points kind of go together. You could find the humps too, those are helpful. But let's move that point over. You can see that I had to go 1, 2, 3, 4 to the right, and 1, 2, I'm not counting by 4s, am I? Look at my graph paper closely. Do you see how that's actually 1? This is 1 unit. This is 1 unit. So I've gone 1 to the right and 1 up. Okay, so now that we found everything that happened to our red function, g of x is going to be the opposite of our f of x function, but we have to move it to the right. So we have to subtract 1 on the inside. And then we've got to move it up. So we have to add 1 on the outside. Okay. So that would be the describing g of x in terms of f of x. It should equal f of x somehow. Okay. So that is number 6. This is now done. Please turn this in. And then if you could please go into iMath. So you'll notice on today's calendar is PC M53. At this time, could you please open that up? We're going to do that together. So the top just talks about some of those transformations. If you want to look at their any of that, please feel free. At this time, we are going to do some of these questions together. Okay. So mine, and be careful, again, we might not have exact matches, so watch what we do here. Okay, so it says that g of x is f of x minus 3. So the first thing they said is my f of x is x squared plus 5. So what is f of 9? Well, f of 9, all you're going to do is plug in 9. 9 squared is 81. 81 plus 5 is 86. So that's what I'm going to put in my first spot there, that f of 9 is 86. Now B says that since g of x is f of x minus 3, what would g of 9 be? Well, g of 9 is just going to be the f of 9 answer, take off 3. So 86 minus 3, whatever you got for your first answer, it's just going to go down by 3. So in my case, it would be 83. Now that should happen every time. So for C here, they want me to check f of negative 2 and g of negative 2. So I'm going to take and plug negative 2 into my f function. So that's going to be 4 plus 5 or 9. My g function is going to take that value and take off 3. So it will be 6. And then I'm going to do it one last time, this time with 5.5. So 5.5 squared is 30.25 plus 5 is 35.25. And I'm going to go down by 3. So that would be 32.25. So everybody try to get your first set of questions great. Everybody good to go on these ones? Everybody turn green. Okay. Now could you please look at the graph they've provided in the next section. See how our f function is in blue, our g function is in red, and all the points, just like we had done on the investigation, those 3 points slid, everything slid down 3, okay? So the outputs changed. The outputs have gone, and they are 3 units less than the outputs of F. So we would say this, for me, it's the first one. Please excuse this interruption. Would Skylar Long report to the front office? Skylar Long to the front office. So you'll notice that our output values went down by 3. Anything on the outside changes the output, the Y value. Anything on the inside changes the input. And then our last little section here, let's go ahead and do this together. There's a table. Now, my function, note what your function does. My function takes my f of x and raises the output by 4. So in the first one, my output is 15. It has to go up to 19. My second output was 6. My output has to go up by 4. I don't know if yours does, but I'm going to add on 4 to that one. This output goes up by 4. Now to go backwards, think about going backwards. If I now know the g function, the f function, if I wanted to think about what is the f function in relationship to g, that would just be our g of x take away 4. So I have 1 there, take away 4 is negative 3. So that's what they're looking for in that first part. Now, for part B and part C, they want you to do the average rate of change formula. You should know that. Remember, it's f of b minus a over b minus a. So our values for me are 9 and negative 1. Okay. So f of 9 minus f of negative 1 over 9 minus negative 1. Please do yours accordingly, whatever yours are compared to what mine are. So if we plug in 9, for me, I get 13. If I plug in negative 1 on the table, you can see I had a value of 6. And then this is 9 plus 1. So in this case, my values are going to be 7 over 10. I guess I did my math wrong. Let's see again. Okay, f of 9 was 1. Wait, f of 9 is 1. I'm so sorry. F of 9 is 1. Oop. Let's check them again. F of 9 is 1. F of negative 1 is, where did I get those numbers? Okay, let's try this again. Okay, so f of 9 is negative 3. Wow, I've lost my mind a little bit. F of negative 1 is 6. And so that's negative 9 over 10. Let's see if they like that. Oh, very good. Okay. Now, if we do it again for the g function, if we use the right ones this time, Mrs. Hott, the g function are my outer values. F of 9 or g of 9 is 1 minus g of negative 1 is 10 over 9 minus negative 1, or negative 9 over 10. Now, Because we have not stretched the graph at all, you should always get that the average rate of change for a function that you have just added or subtracted something to, moved it left or right or up or down, it should not change the average rate of change. So at the same interval. So it should be equal to. It should be equal to. Okay. So that now should be done. I'll give you a chance to make sure that your values are where they need to be. So go ahead and get that turned in. And then we're going to do one other thing, okay? Everybody good with that? Okay, so now go back to your calendar in iMath. If you'll look, everything is due Sunday the 3rd. Please open up the 5-3 day 1 matches this. See, transformations day 1. Please open up that and you will see the questions that we see here. Okay. Now, we don't have a ton of time, but let's do a little bit of these together. So we're going to do homework 5-3 day 1 right now. Okay. So it says that each summer, Primo Pizza and Pizza Supreme compete to see who has the larger summer profit. Let P of X be Primo's profit. And we're going to call S of X Pizza Supreme's profit. Okay. And that is the X is the number of days since June 1st. And the profit, P of X and S of X are both the dollars in profit. Okay, so we've kind of pulled out the information. Let's look at part A. It says, suppose Primo's Pizza's profit each day is 2.6 times as large as the profit. Do you see how it's mentioning the word profit? 2.6 times the profit. So P of X would be 2.6 times S of X. And that's all they want there. Okay. But then it says write a formula for S using the function P. So we know that P of X is 2.6 times S of X. So S of X would have to be P of X divided by 2.6. So I'm going to put P of X in parentheses. So I know that so I can tell them the whole thing is divided by 2.6. Okay. So that is what they're looking for there. Okay. So that's that first section. If you want to try to turn that green, let's do part B. Suppose Primo's profit each day is 240 more than the profit. Now that more than tells us that P of X is S of X plus 260. So we're just going to add, that's output. So let's just put S of X plus 260. So then if you think about if we reverse that process, we would have to subtract 260 from both sides. So this would be P of X minus 260. So that's what they're looking for in that. Oh, let's see. Yeah. I divided by 2.6, but I put the whole P of X in parentheses. So I used a double set of parentheses. Primo's is more than Supreme's. So it is the Supreme plus 260. Oh, it's 240. I'm so sorry. Mine's 240, Mrs. Hott. Please read your numbers. Okay, so that's what they wanted there. Did you see how I entered it with that double set of parentheses? I couldn't get it to do it without that, so. Yeah, I divide by whatever we used in that first section, that 2.6 for me. Okay. Let's take a look at C. It says that suppose Primo Pizza's profit on a given day is always the same as the profit of Supreme's profit 4 days later. Okay, so let's think about it for a minute. Okay, so if we are at some day X, remember that's the days after, the profit here is equal to, that's Primo's profit, is the same as Supreme's 4 days later. 1, 2, 3, 4. And that's the same as Supreme's. Okay. So you'll notice it's moved to the right 4. But if we want to go back and match Primo, you got to go backwards 4. So I believe this is X plus 4. Let me see which way they want it so that I can, yeah, so it's got to be minus 4. Okay, so how can I describe that to you? Wait, did I? Oh, S. Well, then it might have been right. Let's see. Let's see which way it is here. Oh, okay, yeah, it is plus 4. Okay, because it's gone to the right. S has gone to the right of Primo. Okay, so if we want to go the opposite way, I would think this one is the Primo is X minus 4. Yeah, there you go with that one. Okay. So that's question 1. Now, question 2 is almost exactly the same. So we're going to jump now at this time, please, to question 3. Yes. Yeah. Okay, so let's look at question 3. Question 3 says, the values of function g are always twice as large as the corresponding values of the function. That's the output. So we know that g of x is 2 times f of x. The function h, so h of x, is always 4 more than. 4 more than means I needed to add 4 on to f of x. So we're going to add 4 on. So that's what they're looking for there. So the first one, when it says twice as large as, we got to multiply by 2. But if it's more than or less than, we have to add or subtract. In this case, add 4. Okay. Let's see what question 4 looks like. I think that's very similar, but a word problem. Let's do the graph. Where I'm moving on now to question 5. It says, recall that g of x is f of x minus 3. How are they related? So the output, for any value of output, or for any value of x, the output of g is 3 units less than the output of f. And we already did that one before. So that should be pretty straightforward for that one. Question 6, let's see what that looks like.